Good morning, everyone, and welcome to this week's Ironside Take 30 with a Data Advisor. My name is Jeff Spear. I run the information management practice at Ironside, and we'll be talking today about how to plan for data projects leveraging AWS, focusing on some lessons learned to help guide you as you move forward if you're on AWS or thinking about it. So here at Ironside, we want to help you use your data to make better decisions about your business. We've been doing it for over 20 years. We have a variety of practices and delivery areas to help with that. Starting with strategic advisory, we can help with data and analytics strategy, creating a roadmap, making sure you're on the right path to analytic success. We do a lot of design work, including experience design and UX, but also sort of data modeling and making sure you have the right modern analytics framework in place. Building out warehouses, building out dashboards, ML models, a variety of things, deploying them to production, governing them, and that includes master data management, governance organization, tactical governance processes, and then we also have managed services. So if you need help administering or running anything on your analytics platform, we can help with that as well. We announced this morning that we've achieved AWS Advanced Consulting Partner status. This went out on Business Wire just less than an hour ago. So just we're advancing along our path to improve our ability to deliver solutions on AWS, and we'd be happy to help you out. Today we're talking about a series of lessons learned. This is a summary of the lessons. I'm also going to summarize them at the end, so I'm not going to go through them here. We're going to talk about each one of these in detail. The first one being to know your goals. So when you go to the cloud, there's lots of different things you can do. AWS, and we'll talk about this on some of the future slides, really gives you just a vast, universe of services and capabilities and ways to connect things and ways to solve different problems. So it's important to know, what you're going to do, and obviously that starts with use cases. So what are my use cases for going to the cloud? But there are other factors as well. You want to understand what data assets you're going to use, and that has a couple dimensions to it. Obviously, just knowing, I'm going to use data from these systems is important, but also understanding, is all of that data actually going to go to AWS? Is possibly some of it not? And if you have a situation where data is in different cloud platforms, or some is on-premise and some is in the cloud, that can really affect your solution architecture. It is not necessarily a problem to combine data or to do stuff between cloud platforms or on-premise and the cloud. But it may be, obviously, the more data you're moving, or the frequency with which you move it, or the speed that it needs to move at, can make a difference. So understanding what data is involved and sort of casting a broad net to think about, I'm working with this data, but maybe that depends on something else. Also understanding your budget. The cloud is very flexible, very powerful, but it tends to be a pay-as-you-go scenario. So you want to understand how much you have to work with. And we'll talk about sort of monitoring that and setting alerts to make sure that you don't go over that budget. And then lastly, understanding your knowledge workers. And this is a concept from the modern analytic framework, where you want to know who's going to be working on this data and these use cases in the cloud, what skill sets do they have, what types of data do they prefer, what types of data preparation do they prefer, so that when you create your architecture and design your project, it keeps them happy. So this is sort of our categorization of knowledge workers. Those of you who are on the Modern Analytics Framework Take30 will recognize this. And it sort of puts people into a set of categories. And of course, there may be some blurred lines, and some people may not precisely fit into these categories, but this is the idea, and it sort of communicates the concepts that are important. And the first is, what types of skill sets do people have? And so on the left, you have people who are who use more technical tools, machine learning packages, coding like Python, R, that sort of thing. And then on the right, you have people who are more using self-service tools, Office or reporting tools, that kind of thing. So people on the left, like data scientists, they're using more powerful tools, and they tend to prefer data in a more raw state. So a data scientist is probably going to want to look at data without any changes or quality improvements or aggregations, because those things may smooth out some of the patterns they're looking for. Similarly, a data engineer, is generally very versed with SQL, so is okay if the data is in lots and lots of tables. It probably wants it to be in those tables in a SQL engine of some sort, so that they can use their SQL skills to manipulate it, but they're good at doing that. Whereas on the right, people usually want the data to be more modeled for purpose, so that it's easy for them to answer the questions that they have without having to worry about having to manipulate data, which they may also do, but their focus tends to be more on directly answering a business question as you move toward the right. And then in the middle, you have people who often end up using data wrangling. They're quite capable of manipulating data, but they don't necessarily want to have to do the basics. Maybe if the data is cleaned and organized and basically structured, then they can do what they want to do, using a tool like Trifacta to wrangle the data into the format they need, or just using a reporting tool like Tableau or Cognos or Power BI to create what they need. So it's very important when you're moving to AWS to think about who am I building this for, because if you're going to go to AWS to build a data lake and all of your users are consumers, you're going to want to take that data lake and refine it so that they can use the data in a better way and more easily. The next lesson is really understanding the data and analytic environment. AWS has tons and tons of services. It's great because it's so powerful. There's a service to do just about everything. There's probably 2 services to do just about everything, and they're adding more every day. So this diagram is a sample. It's certainly by no means a comprehensive list of relevant services, but it illustrates the kinds of things that you want to be aware of so that you can make the right choices when you're designing your AWS data project. So in this diagram, we have a variety of data sources on the left, of flat files and databases and cubes and cloud or real-time or API data, and it's being ingested into AWS. And so the arrows are 4 example services that can be used to do that. The top one is DMS, or Database Management Service. It's great at pulling in information from databases, either sort of all at once or incrementally. It can sort of listen for changes and push incremental changes into a database in AWS. Glue is AWS's ETL coding service, so you can write Python or Scala code to do data movement, data integration. Kinesis is a service for real-time ingestion, so if you've got data coming in sort of very quickly, you can get it in with Kinesis. And Lambda is sort of an all-purpose AWS service that often doesn't get, it comes up a lot, but people don't necessarily think about it when they're doing data projects. It's great because it's basically a it's conditional trigger code. So basically Lambda can say, if something happens, I want to run this code that can lead to something else. And when you're loading data, you often have those types of circumstances. So, if a file gets put in this S3 bucket, then call something which processes it. So Lambda is really great for that. And we'll talk later about how Lambda is different from some of these other services in terms of how it's modeled and how you pay for it. Then in the next column, we have a series of places you can put data. S3 is AWS's basic storage solution. It puts data in sort of like a file system. It just sort of goes in whatever format you want. It is ubiquitous across AWS. It is very hard to use AWS without using S3. It is likely that you will end up using it somehow, somewhere, but it may not be the best only solution. At the bottom is RDS, which is AWS's relational database service, and that lets you fire up instances of things like SQL Server or Oracle or Aurora, which is Amazon's sort of generic SQL database. And so if you want to do things in that, if you have stuff in SQL Server and you want to do something equivalent in AWS, RDS might make sense. And then in the middle is Redshift. Redshift is AWS's analytic database, so it's more focused on doing large bulk queries with with high performance. So those are 3 places you might want to put data in AWS. And then on the right are 2 AWS options for how you might want to use that data. So Athena originally was a service for running SQL code on S3. They've been expanding it so it can potentially go to other sources directly, or like Redshift and RDS, and they're adding sort of custom adapters for that. You can write your own, so that it's becoming more of a way to run SQL against a variety of sources. And then QuickSight is AWS's sort of reporting front end where you can create dashboards and charts and that kind of thing. So this is just a sampling, and it's some of the key services, but it's certainly not the only services that might be relevant. Additionally, this is a very simplified diagram. It shows everything going sort of smoothly left to right, whereas in reality, things are often going to bounce back and forth. It wouldn't be uncommon for data to go into S3 and then from there to Redshift, and then maybe it might come out of Redshift back into S3 for some other purpose. And so things are going to sort of be used in multiple different ways. One possible use of Athena is as an ETL tool. In theory, you can use Athena to say, select this stuff from S3 and insert it into Redshift or some other S3 bucket. And so effectively, you're doing data movement with Athena as opposed to just querying. And that's really the point of AWS, is that you have all of these tools at your disposal, and they could be combined in many, many different ways. And so thinking about which way is right for you is super important. So understanding, as much of the environment, as much of the options as you can, really helps with that. The additional challenge here, as Mr. Bueller might say, is that life moves pretty fast, and AWS moves at least that fast. They are constantly changing these services. They're constantly adding new services. reInvent is coming up at the end of the year, and they're going to have lots of announcements about new things that have happened. So one example is AWS Glue, which has been basically a more or less command line focused write script, write code kind of tool, is introducing Glue Studio, which adds more of a graphical interface and lets you interface with Glue in a way more familiar to people who use things like DataStage or Informatica or SSIS. So AWS really is evolving and adapting constantly. And so even if you look at all these things to come up with a solution, you want to make sure over time it may be that there's a better solution that you want to move to, or new options for the solution that you chose. So being aware of how things are changing is very, very important. And this all makes, having lots of services and lots of pieces and building sort of what's needed to make different sets of users happy is great. It fits right into our concept of the modern analytic framework, where the data environment has a variety of levels of refinement, starting with sort of raw data like data lakes, moving up to data warehouses as the data gets more refined. And people who are turning that data into value are going to pull data out, and they're going to process to generate an insight, find out how valuable it is, and then deploy it back. And the idea is where the data goes back is going to depend on how much value it's generated. And then you could have a separate team of people automating that process to make sure that the value is being delivered in an efficient, automated way. And so, it may be that some data goes into the warehouse. It may be that some data goes into S3 or goes into a relational database. Finding the right structure for the data to meet the needs of the particular knowledge workers and the particular audience that's using it, so that you're not overdeveloping or underdeveloping your data processing, is sort of a central tenet of modern analytics framework. And AWS really makes it easy to do that because it has such a variety of services. This slide is, I'm not going to go through this in detail. This is sort of a more detailed listing of some of the options in that diagram from 2 slides back. I just wanted to point out that, I focused on AWS services. There are plenty of third-party services that can also be used. So for example, Snowflake is a very popular data storage solution. It's an analytic database in the same sense that Redshift is. Matillion is a very popular ELT tool that will use Snowflake or Redshift as the processing engine, but it gives you a very GUI-friendly interface for doing data integration. And obviously, when you're doing analytics, you could use any number of tools, Trifacta, Tableau, Power BI, Cognos, to do analytics. You're not limited to the set of AWS services. You can have all of these things running against your AWS solution, and those things can be running in AWS. They can be running on premise. You have lots of options. And when we look at the modern analytic framework sort of range of data structures and what data storage you want to use for them, you have a range, I guess. So S3 really can be applied to a variety of data structures, as can Redshift, RDS, Snowflake. And which one is right is partially dependent on the nature of the technology. So like S3, you probably don't want to use for a data warehouse. You could in theory, but you're probably not going to get the best performance. Whereas Redshift is not designed to be a data lake. You're not going to put unstructured data in there. It's not what it's for. Snowflake, you can put semi-structured data in, so it's going to be a little more useful down at this end. And potentially, if your data lake is really more structured or semi-structured, you could use it. But so again, you have a variety of choices, and depending on where you are in this spectrum, you want to look at what your options are and figure out what makes the most sense. So a lot of time on that lesson, but it's a really important lesson, is that there's just a lot of choices even within the AWS services. And so, understanding that there's certainly multiple ways to get to a solution, and finding out the best one is super important. Related to that is understanding sort of components or aspects of the solution. And so I want to talk about these three, which we found to be particularly important. There are certainly others, but these concepts are ones that keep coming up when we look at AWS solutioning. The first one is understanding the different types of databases. So the first type is sort of not a database, and that's really what S3 is. It's file storage, it's block storage. You put data in there. It doesn't do anything particular in it, from a indexing or performance or relationship perspective. It's just a place to put data. But that may be what you want. If you're building a data lake, you want to be able to put whatever you want, wherever you want it, and it just gets in there and you're done. But if you're looking to do, high performance queries, that might not be the best choice. Then there are relational databases. This is SQL Server, Oracle, sort of the traditional, what a database has been for a very long time. And those are good. They're not designed for warehousing in the same sense that some other databases are, but they can do it. And especially if you are low volume, or if that's what you're used to, it makes perfect sense to do. Then we have columnar analytic databases, and this is where Redshift or Snowflake come in. These are databases that are really designed to do analytic reporting. They're great at running these big bulk queries. They're not good at doing 1,000 transactions per second. That's not what they're designed for. But if you're running a data warehouse, or you're running large Tableau queries, those are the best databases for that purpose. And then there's also NoSQL databases like MongoDB. They tend to be used more in operational scenarios, like sort of tracking particular users or those kinds of things. The advantage they have is that they have a more flexible format. So it's easy they're very fast for making changes for individual accounts and users. And they let you sort of dynamically change the structure on the fly. You can add fields and that kind of thing, and not have to worry about, the consistency and design issues that you have with other database types. But they don't show up as much in analytic data projects. So you want to think about what database type you're choosing, because obviously depending on what you're doing with the data, the same database might not make sense for all the different projects or use cases that you might have. When you're doing your data integration, you want to think about a few different things. The first one is it a code-based tool like Glue, or a GUI-based tool like Matillion? Some of this is preference. There are people who like each. Some of it is, how it integrates into your existing processes, how easy it is to maintain. We're a fan of graphical user interfaces because they tend to be easier to understand. A lot of data integration, a lot of ETL, you'll set it up, it'll run for 6 months to a year, and then it breaks, or then someone needs to change it, and everyone's forgotten about it. And so, opening up, 10 pages of code versus a graphical diagram, usually the graphical one's easier to understand, and that helps people maintain a troubleshooting. So thinking about that from a usability and maintenance standpoint is important. Also, are you doing real-time versus batch data integration? So, do you have data coming in on a regular basis, and it needs to immediately get into your data warehouse or data mart or whatever, or is it coming in periodically? This is particularly important on AWS, because which one of those you use is going to affect what services you choose to solve the problem, how those services perform, and how those services are built. And then the last one is server versus serverless, and this is very, very important. It shows up in 2 columns. I'm going to talk about it here and then transition to the cost performance column and talk about it again. Here, a server-based service is something where you activate the service, you turn on a server, and the server is running. And as long as the server is running, you've got the service. Generally, you're going to get billed, by hour, by minute, or by whatever, as long as the server is on. But you get to control when it's on and when it's off. And when it's on, you get the whole thing. And maybe you have, maybe you can bring in a more or less powerful server, and you have to think about sizing, but you have control over that. Serverless is where you don't necessarily have control over that. You don't have to worry about it. There probably is a server somewhere keeping this stuff up and running, but AWS abstracts that from you. So from your perspective, nothing is running, nothing exists until the service needs to be done. It does it, and then it goes away. And generally, so you're thinking about it from a per call or per activation standpoint. And Lambda is a great example of this. So you build a Lambda function to say, when this file is uploaded, call this transformation process. And there's no server, there's nothing that you have to worry about. If no one ever uploads that file, nothing happens. You don't pay a thing, there's no server running that you worry about. The moment that something happens, AWS fires up the necessary memory and hardware and whatever, does what needs to be done and shuts it down, and all you see is, oh, well, okay, I got the bill because that thing was called. So it's a great, for something that doesn't happen often, or something that needs to happen, sort of at particular intervals, it's a great solution. But it has some drawbacks that we'll talk about in a sec. So server versus serverless really is important for ETL because, obviously if you're doing real-time, serverless probably makes more sense. Batch, you have to think about, depending on the nature of your batches, either one could be a good choice. From a cost performance perspective, when you have a server, you're paying for the server when it's on. And so, if it stays on 24/7 and it costs, $1 an hour, then you're paying $24 a day. And so if the server is not being used for a lot of that time, then you're paying for capacity that's not being used. And it's sort of like on-premise. When you buy a server, it's on in the data center, it's on all the time. The difference being in AWS, there's usually a charge. Serverless, you pay by the call. And so, you'll look at it and say, okay, I'm getting called 1,000 times. I'm going to pay, 1,000 times whatever that charge is. So when you're looking at services, you want to think about how that's going to translate to your budget. So if you have something where you sort of need a constant compute load, a server may make sense. Whereas if you have something that is being called sort of relatively infrequently, you may want a serverless service. Often the serverless charge is less until you hit certain volumes, at which point you may be better off having a server running that can just handle as many things as it's physically capable of. The other two factors that come in here are cost and service minimums. So often when you call a service or when you incur a charge, there's a minimum. So for example, a server may be, whenever you fire it up, you're charged for an hour, even if you turn it off in a minute. Or a service may say, like Glue has a time minimum. When you call a Glue job, it used to be 10 minutes. I think it is now 1 minute, but you are billed for that. Even if your job is 1 second or 5 seconds, you get billed for the minimum time. So as an example, if you have lots of really quick Glue jobs, you may be incurring extra charges because the minimum time is higher than your job duration. Whereas if you're calling Glue to do, sort of a massive bulk transfer, the minimum doesn't apply if your job is taking 20 minutes to run. So it's important to understand these things when you're looking at all the services we talked about in your data and analytic environment, to think about, sort of how these things are going to affect your solution. And that plays into the next lesson, which is test and assess. You want to create a solution architecture. You want to use it to estimate what things are going to look like under production, and you want to measure performance and cost. Generally, you want to do this in a new account, and you want to create a budget and set up some alarms so that if the costs go over, what you're expecting to spend, you can find it out and shut it down. It's just like anything else. If you leave the lights on or you leave the car running, you're going to incur cost. So you want something to say, oops, I left this running, or this query is costing more than I expected. Let me figure out why and readdress it. You want to think about compliance requirements, things like encryption, availability zones, and then so you want to get a sense of what your production load is going to look like, and then extrapolate that out so you can say, okay, this is the cost we're going to have, this is the performance we're going to have, and then you want to monitor that over time, because obviously your extrapolation may not be completely accurate, but even if it is, circumstances will change. Your data loads will change, the services themselves will change, possibly the pricing may change. So you need to make sure that what you estimated initially is making sense going forward. And then the last lesson is infrastructure planning. So the diagram at the top here is what we were talking about before from a data and analytics perspective, but underneath that is a whole set of other services covering infrastructure, security, account creation, budgeting, that you need to be aware of. Just like if you were doing an on-premise project, you have to think about your data center and the power and the networking and the routers and all that stuff. Someone has to worry about all that. that is true in AWS as well. This is a slide that sort of shows things that we consider when we're doing an AWS project, and it's probably not complete, but if you think about it, the box in the lower right is really the project, right? It's building the data, implementation. But all these other things, have to be factored in, and if those haven't been done for your organization, then you will probably end up doing them as part of your project. And if you already have an AWS presence, some of these things may have been done for you. You need to make sure they're done in the right way or in a way that enables your project. So these are all things that need to be understood, from an infrastructure perspective, to make sure that you can have the platform that you need to build the project that you want to build. So to summarize, you want to know your goals. You want to know what it is you're doing, with what data you're using, who's going to be using it, and what your budget is. You want to understand the AWS service environment, make sure you stay up to date on it. You want to understand sort of solution architecture aspects like server versus serverless, how those things affect the service cost model and performance model. You want to plan and monitor that cost and performance carefully. You want to plan your infrastructure security configuration from the beginning. You need to have a solid foundation to build your project on. And again, you want to make sure you come back to this periodically and assess it and make sure that it's still doing what you want to do. So thank you very much. And I think we have time for a couple questions. I went longer than I wanted to, but we'll take questions if we have any.
Thanks, Jeff. And we do have a couple, and if anybody has anything else that they want to submit, please do. The first question is, can I build a data warehouse in S3?
So you can. I mean, there's a number of services that let you do database queries on top of S3, including Athena, Redshift Spectrum, and again, there's probably more. So it is entirely possible to do that, and it gives you some flexibility because your S3 is a very free and open way to input data. You're probably going to not perform as well, but depending on the nature of your data sources and how frequently you get queries, that might not be an issue. So it is an option, but I would say it's a rare option.
So the second one is, it looks complicated. Is it worth it?
That is a good question. It can be complicated. There are ways to make it simpler. So, for example, Snowflake is a database that takes away a lot of the administration and is very simple to run. Matillion is an ELT tool that is very simple and takes away a lot of the complexity. But yeah, there's a lot of infrastructure work that has to be done. And just like you need someone who knows it on premise, you need someone who knows it in AWS. Is it worth it? It definitely gives you a flexibility and power and really sort of incremental capability, right? Like once you're in the cloud, you can easily spin up a service to see if it does what you want, pay for a little bit to evaluate it, and if not, it goes away. You also sort of build into this massive ecosystem. Amazon, AWS is building out new capabilities every month, so you really can get a lot of power and a lot of, and I guess a lot of capability out of it. So it's not inherently worth it, especially if you have a functioning data warehouse now. But I would say it's certainly something you should be looking at.
Thanks. And can you comment on if I can run my existing software?
In AWS, yes. AWS, has ways to basically run, virtual machines of basically any type in AWS. So, it is entirely possible to say, I want to take my warehouse and just run it as is in AWS. There's probably some tweaks because it's not exactly the same as being on premise. But, for example, we've seen people take, I use Informatica and I want to keep using it as is. You can run Informatica in AWS just like you run on premise. So yeah, you can absolutely do that.
Terrific. So we're at the bottom of the hour, but if you could just comment on how folks can find out more about AWS, that would be great.
Yeah, sure. So, obviously we're happy to help you, answer any questions that you might have. We're actually, so coming up, we've got on next week, we've got our Take30 on machine learning algorithms, but on the 12th of November, we're going to be doing a Take30 on governance at scale, which is going to be talking about in more detail, sort of how to get started, managing your data and related infrastructure in AWS. So I would say tune in for that presentation.
Terrific. Thank you. And I hope everybody has a great week.
Thanks, everyone.